So let's start with a bubble sort. So the mechanism, what is behind for sorting an elements using bubble sort, and then try to understand the algorithm. That is a brute force approach of bubble sort algorithm, and then you're going to solve a simple example by using this algorithm. And this sorting problem is simply compare an adjacency elements of the given list, and it is going to exchange, okay, when it at the condition. So simply bubble sort is a simple algorithm which is going to compare the adjacency elements. Means side by side elements it is going to compare. Suppose if you have items ai, and this is ai plus 1, and this is ai plus 2, and so on. You have up to a n minus 1 elements, and now it is going to compare these two elements. Okay, so if this element is greater than to this element, simply it is going to swap. Okay, and after that your j get increment, and it is going to compare the next two adjacency elements. Again it will check the condition. If again the condition met, again it is going to swap these two adjacency elements, and so on. So by doing this repeatedly, we end up bubbling up the largest element to its last position. So after completion of first pass, the first largest element will be placed in a last position. And for the second pass, the second largest element will be placed in a second position, and so on. Okay. So this is going to be continued until all the elements of your list is going to be sorted. And after n minus 1 passes, we see that the list is in a sorted order. Okay. And here you can see the pass I can run from 0 to n minus 2 of a bubble sort. It can be represented like this. So here A naught, A1, A2, A3, and so on, AJ. And here we have AJ plus 1. And so on, it is going to be done A n minus I minus 1. And this is A n minus I. And we have up to n minus 1 elements. This is a simple representation of array. Your loop is going to run. And this is a simple algorithm bubble sort. So which will take A of n elements. And we know array of n elements is going to be represented with A of 0 to A of n minus 1. Up to A of n minus 1. So these are the comments given for your algorithm. And the first comment will say like we are going to sort a given array by using bubble sort. And this is a second comment, which is an array we are taken as an input of size A of n, which is represented A of 0 to n minus 1, which of orderable elements means not in order. So output we are expecting again A of n, that is represented from A of 0 to n minus 1. So it is going to be sorted in ascending order. So simple algorithm we have. So we have two loops. So this is your outer loop, and this one is your inner loop. So your inner loop is going to run up to 0 to n minus 2 minus I. Why it is going to run up to here? Because after every pass, right, we are left with that many of elements from the rightmost. So that is going to be achieved by using this line. And then your outer loop is going to control up to what range you're going to compare in each and every pass. And simply what we are going to do, this is a logic, right? This is a logic behind your bubble sort. It is going to compare an adjacency elements. If A of j plus element is less than A of j element, right? You can consider like this, or else you can take A of j is greater than A of j plus 1. Okay, so both are same. Okay, then what simply we are going to, we have to swap those two elements. And we repeatedly do the same thing until all the elements of your list is sorted. So we'll go with simple example and try to understand how we can apply the bubble sort for solving a sorting problem. So this is an example. So we are given a list of elements. So totally here we have 7 elements. Okay. And the first element is 89 and second element is 45 and third element is 68, 90, 29, 34 and 70. So totally we have 7 elements. So the index starts from 0 to n minus 1, that is 6. So because of that, each and every element is represented. This is A of 0, this is A of 1, and so on. A of 6. So that is a representation given here. A of 0 is 89, A of 1 is 45, and so on. A of 6 is 70. So now try to apply our algorithm. So we know we have 2 loops, I and J. This is your outer loop. And your I controls outer loop and your J controls the inner. So now initially your I is 0 and your J is also 0. Okay. So what your algorithm will say, it is going to run up to 0 to n minus 2 minus I. So for the first pass, the pass 1, it will be 0 to n minus, n is nothing but 7, minus 2 minus 3. That is, your J is going to run from index 0 to 5. Okay, so remember this. And then what is the logic we are going to take it? A of J plus 1 is less than A of J. Then we need to swap these two elements. So we have to keep these points in your brain and then start doing the example. So now this is A of J and this is A of J plus 1. Okay, and a first pass in an iteration part. This is the first iteration. So we have to take these two elements. A of J plus 1 is 45, right? 45 is less than 89. So now the condition is true, right? 45 is less than 89. What we need to do? We need to swap. So we need to swap 45 and 89. Simply we are getting like this. And these two elements are swapped and all the remaining elements will be remain same. So next what we need to do? We need to compare these two elements. That is A of 1 and A of 2 and 1 need to compare. That is 68 and 89. See, here consider this list, not this list. Okay. So now here we need to compare these two elements. That is 68 and 89. So 68 is less than 89. Again, we need to swap these two elements and we get this list. And after that, we need to compare these two elements. So 89 and 90. 90 is less than 89. The condition failed. So we cannot swap. So the list remains will be the same. See here, after this iteration, the list will be same. So, and after that, we need to compare these two elements, 90 and 29. 29 is less than 90. Yes, these condition is true. So what simply we have to do? We have to swap these two elements. So we get 45, 68, 89, 29 and 90. So for the next iteration, we have to use this list. So now these two elements needs to compare 34 and 90. So 34 is less than 90. The condition is true. So what simply we have to do? Again, we need to swap these two elements. So this list we are filling. So next we have to compare these two elements. Now we can see 70 is less than 90. Yes, the condition is true. So again, we need to swap these two elements. So now we can find out that after completion of the first pass, you can see the maximum element from your list will be in a correct position. Okay, so you can repeatedly do the same thing. So after the first pass, this is your list and you can see the max position element will be in a correct position. So now we exit from the inner loop. Okay, we exit from the inner loop. So now outer loop is get increment. Now I becomes, sorry, I we cannot see. And then we can see like J. So J is 0 and I get increment. Now it becomes 1. So now your J is going to run from 0 to n minus 2 minus I, right? So that is n minus, that is 7 minus 2 minus I is 1. So that is 5 minus 2 is, so your j is going to run from 0 to 4d. Okay, and remember this. So now your j is 0 and j plus 1 is 1. So these two elements are compared, 68 and 45. So 45 is not, sorry, 68 is not less than 45. The condition failed. We cannot swap them. So the same list is remained. So now again we have to take the next two elements, 89 and 68. 89 is not less than to 68. Again the condition fails. So we cannot swap. It remains the same list. Again, we need to compare these two elements, 29 and 89. So 29 is less than to 89. The condition is true. So now we are going to swap these two elements and allow the listing to be 45, 68, 29, and 89. And 34, 17. And we cannot consider this element. Okay, we are run up to this. We are run up to this. And then we'll see the next two elements is these two. Next, we are going to compare 34 and 89. As 34 is less than 89, again the condition is true. So again we have to swap. After swapping, we get the elements like this. See, this 34 and 89 is going to swap here. And after that, it's used to compare these two elements, 89 and 17. So 17 is less than 89. Again, the condition is true. So these two elements are swapped. Okay. So now you can see 89 will be the second largest element from your list and it will be placed in a correct position after completion of pass. Okay, now you consider this list. Okay, you consider up to this list for the next pass. In third pass, again, I get increment, it becomes 2 and your j is going to run from 0 to 7 minus 2 minus 2. So that is 5 minus 2, 3. Up to third index only your j is going to run. So now you can see, you can take these two elements and now you're going to compare 68 is less than 45. Condition failed. So the same list is remained. And then after that, these two elements is going to compare 29 and 68. So 29 is less than to 68. The condition is true. So we need to swap. So after swap, we are getting the list as 45, 29, 68 and 34, 17. Okay, 34 and 17. Now we need to compare these two elements. Okay, 34 and 68. 34 is less than to 68. Again, the condition is true. So we need to swap these two elements. After that, we are getting 45, 29, 34, 68, and 17. In next iteration, we're going to compare these two elements, 17 and 68. Say 17 is less than to 68. The condition is true. Again, we need to swap. Now we are getting this list. So 17 and 68. And at this time, in third pass, we can see that the largest element, the largest element will be in a correct position. So these three elements are sorted. So for the next pass, we have to consider these four elements. Okay, so in pass 4. So now in pass 4, you have to consider a list from previous pass. So what is the list we are finding? 45, 29, 34, 17. 45, 29, 34, 17. And all the remaining is already in correct position, right? So we left it this. We are not considering these things. And your I is incremented, now it gets 3. And your j runs from 7 minus 2. That is 5. 5 minus 3 is 2. Means your j runs from 0 to index 2 only. Okay. And then we can see here these two elements are compared. 29 is less than 45. Yes, the condition is true. So we need to swap these two elements. Now we get the list is 29, 45, 34 and 17. Again, we need to compare these two elements. So 34 is less than 45. Yes, the condition is true. So again, we need to swap these two elements. We get this listed. So now we need to compare these two elements. So 45 and 17. 17 is less than 45. Again, the condition is true. So then we need to swap these two elements. We get this list, plus 29, 34, 17 and 45. And after the pass 4, after completion of fourth pass, Now we can see the fourth largest element from your list will be in a correct position. So for the next iteration, and for the next pass, you're going to consider these three elements. Okay, so this is a pass 4. So what is the list we have? That is 29, 34 and 17. And all the remaining elements we have like 45, 68, 89 and 80, 90, and these are already in sorted. So now at this stage, I get increment, it becomes 4. And your j is going to run from 0 to n minus 2 minus 4. So that is 7 minus 2 minus 4. It's become 1. So it is going to run up to 0 to 1 only, index 1 only. So now you can see here 29 and 34 is compared. So 34 is less than 29, the condition failed. So we cannot swap, the list will be remain same. So now in the next iteration, it is going to compare these two elements, 34 and 17. So 17 is less than 34. As the condition is true, we need to swap. So now we get 29, 17 and 34. Okay. And then the list is over, right? So now the inner loop get exited. So now you can see after the pass 5 is completed, we can see last 5 elements will be in a correct position. So for the next pass, we are going to take these two elements. Now I becomes 5. I get increment and it becomes 5. And j is going to run up to, that is 7 minus 2 minus 5 is nothing but 0 only, right? So now see here, your j is 0 and it is going to run up to that only. We have only one comparison. So that is, what is that comparison? 17 and 29. 17 is less than 29. As the condition is true, so we need to swap these two elements. And now after this pass, we can see the last 6 elements will be in a correct position. Okay, so by this, we done n minus 1 passes. Because we are now done 7 passes here. See, we can run only 6 passes. So what algorithm will say? It says, right, after completion of n passes, see, after completion of n minus 1 passes, right, after completion of n minus 1 passes, you can see your list will be in a sorted. And we are finding that only here. Right. So after completion of 6 passes, we can see that all the elements of your list is in a sorted order. So now it is a time complexity. So for finding the time complexity of bubble sort, we need to find out the basic operations we are performing with bubble sort. So the basic operations, here we are performing 2 operations actually. So one is comparison and the second one is exchanging, that is swapping. Exchanging or swapping. But we can see that we cannot swap elements every iteration. If it is required, we are doing this. Otherwise, we can't do. So, what basic operation we considered here? For every iteration, we did the comparison. So, the comparison operation will be the basic operation. And here, for finding the time complexity, we have to find out the summing expression, right? And it will be depends on the loops what we are given in our algorithm. So from the first step, when the algorithm is given, you can find out the loops is like this from 0 to n minus 2, and this is j from 0 to n minus 2 minus I. So you have to keep this in your mind for making this expression. You can see 0 to n minus 2, your I is going to run, and 0 to n minus 2 minus I, your j is going to run. Now you're going to simplify this. So I'll show you how you're going to simplify this in the next slide so that you can understand in a better way. So the number of key swaps, and however it depends on the input. And for the worst case of decreasing array, and it will be same as the number of key comparisons. So how many times you compare, and that many of times you're going to swap also. So in that worst case, so we are finding the time complexity of theta of n square. So I'll show you that how we are getting this theta of n square. And now you can see this is the summing thing what we are finding in a previous slide. So now, how are you going to simplify this? We have a formula like upper limit minus lower limit plus 1. So we have to simplify in this expression first. So what will be the upper limit? That is n minus 2 minus I, right? Minus, what is the lower limit? It will be 0 plus 1. So now you have to simplify this. We are getting n minus 2 minus I plus 1. So now you can see after simplifying, we get n minus 1 minus I. So that is a given. And after that, we have 0 to n minus 2. This will be n minus 1 minus 1. So for making simplification, we have to split this for two parts. The first part will consist in, so n minus 1 will take it as out. And now it will be 1. From 0 to n minus 2, 1. And minus of I 0 to n minus 2, I. So we know like I from 0 to n, then summing will be given as n into n plus 1 by 2, right? So now you can substitute n minus 2 because it will be a upper bound here and we have to do a summation. So in place of n, we can substitute n minus 2. So now in place of n, you can substitute n minus 2. You get like this, n minus 2, n minus 2 plus 1 by 2. So now after simplification of this, n minus 2 and this is n minus 1 by 2 and this will be the same. And now in order to reduce this, for the same you are going to apply. So we keep out this one only and for this we are going to do like upper limit minus lower limit plus 1. Okay, so I'm doing like this one, n minus 2 minus 0 plus 1. So we are getting n minus 1 here. So now you can see n minus 1 into n minus 1 minus of and this expression you have. So you have to simplify. We are making n minus 1 is common in both expressions. So n minus 1 and here we have n minus 2 by 2. After we're doing LCM and we are getting like this. And after that we are simplifying. We are get n by 2 here and minus 1 here. So now we are doing a multiplication. We are get n square minus n by 2 and we simply be written as 1 by 2 n square minus n by 2. So we know for the order of growth we have to keep means like as a constant C in plus n or something, we have to eliminate these constant value and we are taking this exponential value as your order of growth. So for that you have to consider this n square and it will be theta of. In this way, we're going to find out the time complexity of bubble. So I hope you all understand.